Hello, and welcome to our Utility Roundtable webinar. My name is Jack Hobson. I'm with SBS, and today we're going to be discussing intelligent substation design. Our panel is a group of utilities that have been doing intelligent substation design for a number of years now, and they've been kind enough to join us to share their story today. And with that being said, I'd like to introduce them at this time. First, he is the Protection and Automation Manager for Southern Company Transmission, Mr. Bill Gordon. Bill, say hello.
Hello.
Thanks for joining us today. And next, he is the Manager of Design for Ameren Transmission, Mr. Donald Sanders. Don, it's good to see you. Thanks for joining us.
Yep, great to be here. How you doing?
I'm good. I appreciate it. Don, for our audience, Don had a knee replacement surgery, full knee replacement 2 weeks ago. So again, thank you for joining us. Appreciate that. And last but certainly not least, he is the CAD and GIS lead for Lincoln Electric Systems, also known as LES, Mr. David Mueller. Dave, again, thank you for joining us today.
You bet. Glad to be here.
So, gentlemen, we have about 35 minutes to kick right into this. And so I want to hit the ground running. And for our audience today, we will be taking questions for the last 10 minutes of this webinar, and we'll let you know when you can start submitting those at that time. So, guys, instead of all of you sharing your history of how substation design has went in your utility, it's a pretty common story. So most of the last century, you did manual drafting. In the 80s, 1990s, we had this paradigm shift to CAD. So whether that was the personal computer or these massive CAD machines that required these climate control rooms, that was a huge paradigm shift at that time. I certainly had the privilege of working with people that went through that. And not only were they learning CAD, they were also learning the personal computer because a lot of people didn't have computers at home. And so fast forward 20, 25 years later, the evolution of 3D, although we've always been able to do it within CAD, it certainly has gotten better for the last few decades. And now we have these utility-specific tools. So would you say that that is pretty much a common theme story with all three of your utilities?
Absolutely.
Yeah, no question.
Great. Yeah, appreciate that. So with that being said, I mentioned this paradigm shift with intelligent substation design. And so my question to you guys is what instigated your interest in utilizing intelligent substation design, and how are you using it today? And Bill, I'm going to start with you on this because you're one of the earliest utilities that started implementing this technology.
Oh, absolutely. I mean, I think our initiative kind of kicked off in 2013, and it was really around individual contributor employee seeing something on. Actually, we're doing some stuff around lean processing and a bunch of different things, ideas around efficiencies, and then saw something on this software, started another conversation, brought it to a GM. Just simply said, hey, why are we not doing this? Why do we want to be last? What can we do to get this going? And from that one conversation really kicked off really the whole project. It started the investigations, looking out there what was available, and then starting to look at vendors and where do you go from there. So just simply one person having the idea and getting the ear of a general manager to sit down and have a conversation.
That's great. And yeah. So how about you, Don? What instigated Ameren to jump into this intelligent design?
Well, we didn't want Southern Company to be the only one, we want, but how about the FOMO, fear of missing out, right? And
yeah.
We wanted a part of this, and talking with several utilities and getting involved with that consortium, and also having a design supervisor with a little energy to get it going at the company. One, Jack Hobson, he used to work for Ameren and certainly started that path for us on the physical side. And then we kind of in parallel also started on the electrical side. But so that's really what instigates it is, you got to have that interest, right? You have to get better at what you're doing, and you can't just keep kicking the can, right? You got to know where you need to improve and what you need to improve on. You got to build yourself a team around that. You got to have a plan, and know you're not going to do this on your own. This is something when you build a team. Jack Hobson, you can just say it. You didn't go and do this on your own. You built yourself a team. You had a plan, and you wanted to take your design to the next step. And that's that's really the excitement. That's how all this gets generated is how do I get there? Uh, Bill Gordon doing it down in Southern Company, and hell, we can do it too, right?
Yeah, for sure. Yeah. So Dave, same question for you. You know, the last time we saw each other was at the System Protection and Substation Conference about 2 years ago, and you and Ryan were giving a presentation, and the things you guys were talking about, I was envious, to be quite honest with you, because years ago, that's in my head where utility substation design should be going. So certainly excited to hear from you. What instigated your interest, and how are you guys using it today?
Sure. So for LES, it's kind of right in our mission statement to be a progressive leader. And in order to do that, you have to be willing to adapt. You have to be willing to change, seek out new ways of getting work completed, whether that's efficiency gains or safety gains or precision. And kind of like, you know, Don said, you can see other people around you doing it. You see other industries doing it. So I think utility industries may be a little bit behind where some others have moved into model-based design. So if you see them doing it, say, how can we do it? And for LES, they had some of that software in-house already. So it was just finding a way to put it to use. For me, personally, in my own journey, it was a lot like Bill said. I was working for a consulting engineer, and then it's kind of the same thing. He saw some 3D model parts and said, why aren't we doing this? And so he was willing to take one of his substation projects and say, don't worry about the budget. We're going to model this, see what happens. And really, and I think the other two can say this, once you dip into this world and get into this intelligent design, the benefits of it just far outweigh any risk that you thought you might have had before you've done it, whether that's the speed or the accuracy, the ability to replicate things much faster than you ever could in the older workflows.
Yeah, and just another minute on the topic, Dave, while you're still talking, a lot of the things you guys were playing with was LiDAR scanning and even reality capture of your vaults. Could you talk about that just briefly? Because I really found it fascinating.
Yeah, so we have a reality capture program here where we've got two LiDAR scanners, and we scan substations, power supply generators, or generating stations. The vault one that we talked about in the past, we were building a new downtown network vault, and we used our scanner to scan the concrete, get a point cloud model of that, bring it back into the office, and then we could model all the equipment around what is actually out in the field. Because everybody knows, you know, when you've got something large and you go to build it, nothing ever goes exactly per plan. But now we had that exact structure that we could model our equipment to. And that worked out very well.
That's
And we
great.
can
And
apply that same process to substations. You scan your existing substation. Now you have a point cloud model. So you have a digital copy of what's actually out there. You go to replace a breaker or replace a structure. You can model everything new, match it up with what's in that point cloud, and you save, in some cases, you could save a lot of headaches, you know, where in the past you'd go off of an old drawing that could be decades old,
yeah,
and out in the field conditions are different, and you won't know that until you start building it. And we all know that when you have to make changes during construction, costs go way up compared to making changes digitally during design.
yeah, for sure. And Don, you guys have done some 3D scanning as well, correct?
Yeah, so we're just starting to get it kicked off with our scanning process, and that's mostly on the maintenance side. And so they're seeing the benefits on getting that scanned and maybe saving themselves the trip to the sub.
Mhm.
And I know Dave's talked about that with us earlier. But we're then we want to see when we have that scan, what do we do with the point cloud data and how we can integrate that in our design process all the way through Inventor and start building off of these the older infrastructure. I think we can nail all the greenfield sites pretty easily and build those, but how everything is just not new, right? We got a lot of old infrastructure and we're going to scan it. So what do we do with all the point cloud data? So now integrating that and getting the team involved and seeing what we can do, not only from the maintenance side, from the design side forward.
Good deal. Yeah, no, that's great information there. I want to jump into the next topic here, guys. One of the common themes all of you've talked about with that last topic point was, trying to do things more efficient, being able to save some time and cost. So with that being said, how has the technology impacted the efficiency of how you're designing substations? And the more specific you guys can be, the better. So whether that's cost and time savings on a project, as an example, or projects over a duration of time. Don, how about we start with you on that question?
Yeah, so let's talk on the electrical side, Jack.
Yeah,
And
for sure.
yeah, so we get some really good results, and I'll just tell you about. So when you automate this kind of stuff, right, you're reducing the human error, right? You're reducing a lot of errors up front in design, but then all of a sudden you see that coming back on as built to where there's less error. But then also when you have an as built on these intelligent drawings, you're changing it in one area, and that incorporates through a lot of other drawings. So you're saving so much time through your as-builts, changing it in one place, and it's spiraling through others. So we've seen that. So that's definitely a benefit on the as-built side. On the design side, if you're looking at doing your old standard 2D or dumbed down design or whatever it is, we're looking at a change from 132 days down to something like 57 days. So you tell me that's 75 days difference right there in design from the time savings, and then you're gonna see that cost from every project moving forward from there. And then we used to have two people doing electrical design. Now it's down to one person does the whole design. So you're cutting it from two to one person. So
Sure.
Jack, you're looking at a savings, anywhere between $50,000 to $300,000 per project. And also think about this too. And I don't know how much Bill and Southern Company does this, but all the projects that are consulted out and the consulting prices these days, you more that you can keep in house and do more in interior design, because we've built maybe 11, 13 subs over the last few years complete. We got like 21 in the hopper, right? We're just continuously doing this, and that's avoiding going outside with those costs to a consultant that can get up 100,000, 200,000, 300,000, depending on the size of the substation. So look at the cost savings that you have there, keeping it in house and being able to do more with your own design. So
Yeah, no, that's great. And how about you, Bill? How about some of the cost and time efficiencies that you've seen?
Yeah, absolutely agree with Ameren there. No ifs, ands, or buts. There's proven project after project. I will tell you, it's a slow start.
Sure.
When you first start doing it, everybody's got to learn a new tool. Everybody's got to get through there. You might even see extended times. You think about a standard 8-week distribution in regular old AutoCAD, and might take 10 or 12, and the next one they do might take 8. And before you know it, you've got your average person doing it in half the time. So cutting it in half, and some of your rock stars, because we've all got rock stars here and there.
Absolutely,
and
yeah.
They're knocking them out in 2 and 3 days. But to me, beyond just the time savings and doing the design, taking the approach when we first went in to eliminate those things that folks hated to do. So if you think about taking an elementary and a wiring diagram and a highlighter, because I'm sure we've all done it, you go out there and you check that stuff back and forth till you're blue in the face, and you do it weeks on end, and being able to eliminate some of those checks based off of some of the automated checks that are in the tools that we're able to use, great savings, and it's data oriented. So when you think about data oriented design, you've got your graphical representation, but the data that's in there is malleable. I mean, we can twist it around, we can turn it, we can move it, we can change it. So when we see things like a 52 panel project on the control side, everything's rocking along, it's scheduled to be a 12-month design or whatever it happens to be, And you go, okay, things are great. You're 3 months in, you're 4 months in, and all of a sudden something happens somewhere and it makes them go, oh, we need to swap these two lines. We need to move all these panels from here to there. So scope change, right? You start seeing scope changes where you're just rearranging everything. And in AutoCAD, that meant you spent weeks and months changing labels. We can fix that now in 15 minutes. We can move one panel from one spot and move it over in a matter of minutes because the data-oriented side of it. So huge savings. I don't even want to guess that last big project. We cut it by 5 months, so it was about 7 months to complete that project instead of a year. And it's huge, and it saw 3 of those exact scope changes.
So just so I hear that number correctly, what typically would take a year, you got finished in 6 to 7 months.
That's right.
So that's half the time.
That's half the time on that particular project.
And that's 50%. That's incredible.
We're seeing.
Yeah, that's very similar to us, Jack. That's instead of a 3 to 4 month project, you can look at a 1 to 2 month project for sure. So it's certainly common with both Southern Company and Ameren for sure. And Bill, I guess something that I'd want to make sure, because I don't know how many folks we have on as listeners, but this is not a 2-week process. This takes a while to get to this spot, and standards are huge. So you start building yourself these templates and these standards, 3 position, 4 position, whatever ring bus. There's where you get that, where Bill was saying, you'll be able to change this around in a few days really quick. It's because you took the time to build the standards, and now the next person is going to benefit from that. So that's a huge, but you're going to trip and fall. It's going to take some time. It's not a 2-week process. It's not a 1-person job. It's a team effort. It's maybe 2 year. I mean, it takes a long time. You can talk to some of our design team, Matt Sumsky and Steve Jackman, and some of those people at Ameren. They'll tell you that takes time. It just doesn't happen overnight.
Yeah. So Dave, while we still have a few minutes, how about you guys? How have you seen a time and cost perspective savings from implementing intelligent substation design?
Sure. Just first, on what Don just finished up with, I like to tell people who are looking into this, the easy button, it doesn't exist. It takes time. You might see a presentation and everything looks just fantastic and amazing, but trust me, it took time to get it that way. As far as efficiencies on the physical side, or the physical drawings that they used to do, it might take a month or better for a package. And I'm talking fence and foundation as a package, steel and bus as a package, your grounding plan as a package. We can now kind of wrap all of that up and get basically an entire physical substation drawing construction issued package in about a week and a half, where
really?
Before it would take a month or better. That includes bill of materials. And when you think about it, before you'd get probably a printed out set of steel and bus plans, and your engineer would be flipping through the plans and counting quantities and then figuring out descriptions and all of that. And all of that is automated now. Let alone, engineers like to make changes. So you get something done and then they'd want to change something. And now you had to change, before you'd have to change it on a plan view and then an elevation view and then maybe in a schedule. And now you change it in your model and all of your drawings are changed right with it. So that's the time saving. I did talk with our substation engineer here. And while I didn't necessarily get an actual percentage, he said for engineering, doing the model-based drafting and design is a huge benefit to them as well. Instead of having them sketch out each one of those packages, they can essentially give us a 1-line diagram of the substation, and we can turn around and give them a pretty complete entire substation package for them to now review and make any changes that we need to make.
So just to focus on that timeline you mentioned earlier, you said over a month, and then you were able to get a package out in a week and a half. Did I hear that right?
Correct. Yep.
I mean, that in itself is also phenomenal. I mean, you took 4 weeks to 1.5 weeks.
Right.
That's
all
quite,
part of that intelligent that intelligent process. I think that I'm hearing comments from Bill and Dave and I is you have that one drawing, and it could spiral and change a bunch of drawings with a couple of clicks here and there, and that's really a part of this intelligence behind the scenes that takes time to build, but then you end up seeing the benefits at the end when you have these changes that you need to come back through and make on these designs.
For sure. So in the spirit of that, I mean, Don, you're telling me, a project, has got efficiency gains, Bill, 50% efficiency, and then, Dave, obviously what you had to take 4 or 5 weeks to do, you're doing within a week and a half. So with that being said, obviously for internal budgets and internal timelines, fantastic. How about what is the benefits from a customer perspective? So some of our audience may not be fully, aware of what substation design is, but they may have a connection to the utility industry in one way or another, but we all pay for electricity. So what is the benefit to the customer? Dave, how about we start with you this time?
Sure. So as everybody can expect, a higher accuracy design being done more efficiently is going to lower costs. It takes less amount of money to produce the same amount of work, and that goes straight into your electric bill. That will show up there. So it does help, keep rates down, keep our customers happy, and it gives a benefit to the employee as well doing this design, and not really as far as benefit to the customers, but benefit to employees. Technology is always changing, and staying on top of technology keeps things exciting for your current staff. It also helps you when you're trying to hire and look for those rock stars that you had mentioned. Because coming out of school, they're not doing the 2D drafting anymore. They're doing the Inventor work, they're doing the Revit work, and so that was another driver, I guess, that instigated this change. But that's also a benefit to your workforce, which always translate out to your customers and your bottom dollar.
Yeah. So I'll throw the same question to Don because I'm a paying customer. How does this benefit the customer implementing intelligent substation design?
It's good you still have your power on there, Jack. So you know what? I echo a lot of stuff Dave is talking about. I mean, you're able to do more design work at cheaper cost. That pays forward. All that stuff that we've been talking about goes all the way through to the customers. And one of our main focuses is and in many areas, we want to improve our grid reliability. We want to meet our energy needs, and we want to have a cleaner energy, right? Well, we're building more substations, more greener substations, more of them, providing better reliability. But now everything Dave said and more is we're doing this more efficiently. We're doing this cheaper. It's and I love what Dave was saying. It's like that excitement is there. There's people excited to do this, and we're just going to get better, and we're just going to see even more savings at the end of the day. So yeah, I mean, we're doing some really good things across our service territory, and design. A lot of this starts on the design side, and however we can be more effective, right? Cheaper, efficient, all the above. The more that is passed through down to the very end, paying it forward. Absolutely.
So, Bill, would you confer with that?
Absolutely. I mean, I'll add to it. You talk about the constructability and the stuff you get at the end of the design phase. When it's more accurate to begin with, the outages are shorter, reducing cost. There's less time that maybe you've got to have a substation out with a temporary mobile there or fed from an alternate source that provides a lot more exposure. It just helps drive reliability. I mean, there's 1,000 different little things, and that's what some of them are. I mean, if we look at design cost on a large substation, design cost isn't cheap, but it's not the big bucket, right? It's the little bucket. But that little bucket impacts the big bucket so much that when the materials are right, you ordered the right stuff, you don't have to bring stuff back, when you got ready to hook up that piece of steel or that conductor, it was the right length and my holes match, and I don't have to go fabricate stuff on site. I mean, the costs go through the roof.
Yeah.
So you're seeing all that all the way at the customer level, because I mean, let's face it, without our customers, we're nothing. Right?
Yeah, and intelligent design equals smart construction usually, right? I mean, yeah. And this is important because, I mean, obviously there's a lot of, political talk about infrastructure spending and, a lot of investment in that. So I mean, this kind of technology certainly helps drive those things. So let me flip the question just for a second. We were talking about customers, and this next question probably really just refers to Don and Bill, since you work for investor-owned utilities. But one of the big conversation pieces inside a utility is always total shareholder return. They refer to it as TSR from an investment standpoint. So flip side of that, Bill, we'll start with you. How does implementing this technology affect total shareholder return TSR?
Well, to me, there's a lot of avenues. I mean, you can examine from this. One is, just return on investment of the product. Do you get it fully implemented? Do you get there? What does it cost to get there? All those types of things go into it. And as the quicker you get that back, of course, the better off you are. But beyond that, when you start seeing, those design costs or that O&M cost or however those get impacted, when you look at the way our rate base works and how it goes back to the customer, when it helps improve that earnings per share or the total shareholder return, I mean, that's going to bring your stock price up, right? When you're seeing those bigger dividends, and again, that's another adder to it. So again, a bunch of little pieces start adding together, and your total shareholder return continues to grow and to grow.
Yeah. How about you, Don, on your perspective?
Oh, that's everything Bill said and more. It's think about all the money we spend, all the capital projects that we spend, and being in the investor owned like this and shareholders. What is our rate of return? Like, how fast can we get it out in design? When we can get it back? How much are we getting back? So what is that price? And it's like, I'm not giving away the farm,
Sure.
I'm not giving away the farm here, but I'm just telling you that, we're going to do all these capital projects and we're going to put them all out on this reliability grid. What are we going to get back? And then how can we then pass that through our shareholders? How does that raise and lower our stock price? That's left to be unsaid, but we're doing everything that we can to see how that can be affected and how that level can go up and down. But everything that we just said on the previous question as well, so, and paying that through, Jack, it's from the design side, being at the cheapest, still every little bit will help. We can't state that enough. And then watching your O&M, right? Keeping that O&M flat. And then how do we get our capital dollars from what we spend and then what we get back?
Yeah. And I mean, again, from my perspective, to try to make it as simple as possible, if I'm investing money into a utility, and if you tell me, hey, yeah, last year we didn't have intelligent substation design, but this year we're doing things, and I'll use that round number. I know it's a variable depending on projects with what you guys have talked about, but 50%. So to me, it's like you could do double the design. That's like double the substation. So that's, if you could do double the substation projects in a year with investment money, and then that makes a more reliable grid, down the road. I mean, again, I think this is why when we look at implementing technology like this, if you could almost double, if not maybe even in some cases triple your production rate, I mean, that's incredible. You can do more with that dollar.
Yeah, I mean, I've heard things like 99% of our cost that people were charging their time to are these capital projects, right? Mm-hmm. Look at the amount of time that we're spending on capital projects. How can we make this cheaper for our company and for our customers? And every single one of these individuals on this call are trying to get there. And I bet you a lot more of your audience is the same way. We're trying to do this cheaper. We're trying to do this more efficiently. Innovation is huge, and we want to get there.
Yeah. Yeah, no, great information, guys. I really appreciate you sharing your stories and your viewpoint on this. And now we are at 3:32 Central Time. At this time, I invite anybody to submit some questions. Once they're submitted, I will ask the panel what the questions are. If there is a specific person, company, please, help me point it in that direction.
Or Jack, you can ask the questions.
I could ask some more questions while we're waiting.
We can ask you questions.
Here's a
Jack.
bonus question while we wait for some questions. A lot of you guys are doing stuff in renewables. That's certainly a huge focus. Is this going to help you with that? Oh, actually, we do have a question. Let's pause on that one. Are you having any experience with improved construction safety within implementing intelligent substation design?
Improved safety. I don't think I can really answer that one, Jack. I don't believe that we've seen any results on the safety side from it yet. But we haven't really done the physical design. Maybe Dave on the physical side.
Yeah, Dave. Yeah.
So I don't know necessarily about construction safety, but safety overall, sure. Especially, talking with the LiDAR scanning, because we can get that scanner into the locations that I don't want to say unsafe, but might be kind of dangerous if you're not, fully educated, fully trained, fully qualified. And we can collect that information, and then people can consume that data, that information from their desks instead of being out in that scenario, out in that situation. So there's definitely an improved safety aspect there. But as far as construction safety, I don't know. I suppose if you had a very kind of one-off or odd design, maybe a distribution pole with a lot of stuff on it, we can model that up ahead of time, and there could be safety there because then field crew could see it from a lot of different angles other than the old-fashioned just plan and profile view. That could add some safety there.
Gotcha. Okay. Next, a good buddy of mine at one of the consultant firms has asked that you go easy on the consultants. Okay. Talking about pricing. Good stuff here. And the next question.
Were we?
Next question. Does anyone have metrics on savings on construction change orders? What is the trend before and after?
I will say we do have metrics on field changes. So not necessarily, we don't really use a change order system, but just from the constructability on the control side, particularly where you typically wind up with a changing some labels, changing some wiring, you get a little more personal preference here and there, and being able to try to evaluate that sometimes. Is that really a problem, or was it personal choice to do so? But overall, those numbers, as we've strengthened in both standardization in those realms, as well as using these tools, the number, just sheer number of field changes, probably down at least 50 or 60%, if not 70%. So you do a large project and it has a lot of field changes, it's probably because of some scope changing during the construction phase. So we're really not seeing that many changes. One of the first projects we did it using AutoCAD electrical and all the tool sets was a fairly simple 3-terminal ring bus. And you could expect from that there's probably going to be 10, 12 field changes on something. It had one print. That's it.
Really?
So that in itself kind of showed the accuracy of applying those standard, templates, we'll call them, into that project. And it was greenfield, so again, makes it a little easier.
Sure.
But it sure does. It sure does show when you look at, just the sheer number of field changes over the last 2-3 years and how they're going down. They continue to reduce, even though the capital spending is going up, the number of field changes is still going
Okay. So I'm going to go to, we're getting a lot of great questions here. So I'm going to jump to the next one here. How did you get your IT team on board to support the software purchase and maintenance aspects?
The IT team, did you say, Jack?
Yes. Mm-hmm.
Well, I mean, just from our perspective, I would say when you're putting this plan together, again, you're not on your own. You better start involving your different parts of the company. One of that is IT, and when you're involving IT, then that's part of your business plan. What are the costs going to be? That is openly communicated from the start, from with IT, with your team, um, and then as you start moving forward with your business plan, that software cost, depending on the amount of software that you get, how do you want it? How does that spent? Is that capital? Is that O&M? And then what is from IT? What is coming from out of IT's budget, and then what would come out of your design budget? So that should all be communicated up front with your plan. But I if you're not going to start off. I mean, we didn't start off huge, as you know, Jack. We
Sure.
started off, a few licenses here and there, and we built it up, as we knew how it was effective for us, and then we built it up from there. So we didn't generate a huge cost up front, because we just started building small blocks at a time.
Mm-hmm. Dave, how about you? You're a little more nimble, being the city co-op. How about your IT team in implementing?
Sure. So I think overall, these kind of things like today, if you could get those people to listen in here and hear from other utilities, other companies that have done this, and you can hear the benefits of it, see the benefits of it, and then like Don said, you start small. And here at LAS, we kind of did a proof of concept. So we had a substation that was built based off the old design, 2D design. So we had metrics there, and then we took that same substation and we modeled it, and we did it in a model-based design, and then you could really compare time savings, which equate to costs. And if you're not doing this model-based, this intelligent substation yet, if you heard me talk at any of these kind of things before, I always preach hardware and beefing it up and buying the best thing you can. But if you're already doing 2D CAD drafting, your hardware is probably good enough to at least start in an
Sure.
intelligent substation design. So you could save some costs there by looking into what you already have, and using that as a starting point.
Yeah,
Unless you have LiDAR scans.
Yeah, Bill,
So even that though, the LiDAR scanner. So we started small. We bought a very small unit that was inexpensive as far as LiDAR scanners go, and we used that several times, and we proved what it could all be used for, and how it could help bring costs down in other areas, and that led us to purchasing then a larger, more outdoor kind of commercial scanning unit.
Yeah, and for the audience out there, to maybe put a little perspective on it, when we say talking about starting small, Don, when you and I were talking about pursuing Intelligent 3D, I had picked a 34 4 kV station to do that because it was the smallest station. It was more or less the bread and butter distribution. And again, I had picked a really great team of people to pursue that. So again, it was like, we're not going to do a 345. It is better to start small and grow. So whatever your smallest substation is, I would recommend trying to start there for sure.
And you talk about IT. This individual was talking about IT. IT is not small. You have to think about everything that IT is going to provide for you, from a server side, on a database side, software. You need to get them involved at the beginning and start your proof of concept and your business case with them from the start, because there is a lot involved with IT. So this ain't no joke. There is a lot involved with IT. It's just don't go off and venture out on your own on this at all.
Yeah, let's we got about 5 more minutes here. I certainly want to jump into some questions here. I apologize for not being able to get to all your questions. You guys have submitted some great ones, but I do want to take one from a consultant perspective. Obviously, this is a group of utilities here, and it's a fairly long question, but I certainly want to go through this here, so bear with me. As a consultant, we are in the early stages of converting to Inventor and feeling the growing pains. We hate to lose great clients and are trying to grow. We find that almost every client wants things done differently, and of course, every site is different. How much actual engineering goes into each project, and what would you suggest to maintain the design relationships we have established over the 70 years while providing enhanced services? So to condense that, what advice could you give consultants that are, again, just getting into this, are thinking about, trying to field their way into intelligent design?
Talk to the utility, talk to their customer, make sure that what they are, who are they providing the service for, and what type of software and what type of design is involved in that company. It's communication, really. I don't know what else to tell them, because the consultants that are working for us are communicating with us and using our standards, and we provide them with everything that they need, like they were inside of our building working. So it is heavily communicated with that company that they are doing the service for. Heavy.
Yeah.
Yeah.
And that's good.
Agree with that. Making sure the communication's open, making sure that expectation is known there on what does your customer expect from you? Do they expect you to abandon your 2D ways, we'll call it, and move over? Or is that going to be a limitation? For me, getting that word out well in advance of kind of when we want to transition everyone to that is very important. And then being there to help. We understand that not every contract firm out there has been doing AutoCAD Electrical and Inventor for the last 10 years. It's almost 10 years for us now.
Mm-hmm.
But that's not the expectation. And how do you bring it along? But knowing that we have these tools and we have this, and this is what we expect you to utilize, kind of like what we have in the CAD standard. I think a lot of folks had CAD standards, Southern included, of you'll use this text, line weight, you'll do all these things kind of documented. We've turned around and done the same thing on these intelligent tools with the associated expectations, and just ask for that. Well, how are y'all doing it? How are you, the customer, or our customer, doing that today, so that we can at least start looking and playing and replicating some of that and see where our own internal barriers are, and how do you get it? But as Don mentioned, it's got to start with communication.
The consultants are very important to our business. And as our projects go up, our tail off or whatever, our consultants are so important. Now they're expensive. They had to jump that in right now, but still very important to us. And so if we're not communicating with them, they should be asking us the questions. And also, just like this, Jack, and everybody that's involved in this is this SDSIC. This is not just utilities anymore, right? This is all consultants as well. And that is heavily communicated through all different channels and all utilities. I don't know of very many utilities that don't use consultants, but we want that communication. That's huge.
For sure. I'm going to go ahead and hit off the last question. That being said, there's a lot of questions I didn't get to, and I've been scrolling through them. A lot of great questions for you guys. I certainly just want to respect your time, since this is a 45-minute webinar. So we're going to do one more question. And I like this question because I've certainly had this conversation before, which is, do you anticipate adjustments in your staffing levels based on the levels of savings and how you are expanded into accounts for time savings? Where are these savings, engineering time, design drafter, etc.? I'll kick this off with my opinion. Usually what I find is, particularly with substations, if you can do more, you end up doing more. There's just not a lack of projects out there to say, oh, we'll cut the staff, by 1/3 because we can do the same amount of work. Usually it's, no, we can now do more substations. Am I correct or am I incorrect on that?
Oh, you're spot on, Hobson. I'm telling you that this question comes up quite often over the last few years, and we'll do more. We are able to do more design. And I know the consultants can close their ears because we'll be able to do even more in-house, right? So more in-house, more design, keep them coming. What more can we do? Because last time I checked, our budgets are still shooting up, right?
Mhm.
We're still getting work. It's still coming. We still have to improve reliability. We got renewables. I know you touched on that a little bit. We got to better our infrastructure. So projects are coming and we'll do more of them. We're getting better, more efficient. We'll do more of them.
Yeah.
With
And I
even
definitely
more
want to hear
people.
from Bill and Dave on this as well. So how about you, Bill?
Yeah, absolutely. We will not see a change in internal numbers in terms of the design team. We just won't. I mean, today we're contracting out anywhere from 60 to 70, say maybe even 75% of the work because the volume is simply so high. And it's not going down in the 10-year forecast. It's every year is going up.
Yeah.
So from that standpoint, it's just like Don said, it's just going to be more work done inside as the team gets more and more efficient. You just keep growing that on, you keep growing it on. And as that pushes out to the design firms out there, guess what? That expectations is coming to the design firm. We expect to start doing it this way. We expect to start seeing these costs to design to go down, and thus the number of projects to go up for a given spend with a contract.
Sure. And Dave, how about you? You're a little bit of a different organization.
Sure. Yeah, we do a little bit more, or not more, but a little different. So I work in substation, and we also help our transmission group, our generating group. So I don't anticipate any staffing adjustments due to the efficiencies, but possibly the work that staff does could change for sure. I made the example earlier about the engineer with the printed out set counting up quantities. They don't have to do that anymore. So instead of the time they were used to spend doing that, they could be, working on their specifications or coming up with a new structure or any number of things for engineering, for drafting time. Now that's cut way down, instead of spending your whole day drafting, you might be drafting and scanning with our LiDAR scanners. So we found as the technology has improved and we've dived into this technology, we find more and more case uses, more and more reasons to do it, and more things to do it on and do it with. So the work will be there and the work will grow. What you were doing yesterday might not be what you're doing tomorrow, but it'll get done. And I don't really anticipate any kind of changes in staff.
Gotcha. Thank you for your answers on that. Again, I'm going to apologize that there were a lot of great questions here. And it's always that hard balance of respecting time versus, not knowing who would just like to keep going forward. Maybe we'll do another one of these. And, there's a lot of questions on brownfield, guys. And, we more or less talked about implementation and cost. And, maybe we can get a chance to do another one and talk about maybe brownfield specifically. But at this time, I want to thank our audience out there. I want to thank all these great questions that came through. And again, apologize for the ones we couldn't get to. I want to thank the people behind the scenes at SBS, Taylor, Ethan, for helping me out, put this together. And of course, our great panel here, Don, Bill, Dave, thanks again so much for joining us and giving some insight on the hurdles and the efficiencies and the rewards of implementing intelligent substation design.
Thank you very much. I would say get involved, do the research, talk to others in the business. That's what we're here for. And we still have a lot more to grow ourselves. So we may be contacting you as well.
And a good sign off, the Substation Design Industry Consortium is next week. So if you do have a chance, SDSIC, I would encourage you to sign up, get involved, and attend a lot of those webinars as well. So again, thank you guys. Thank you, audience. Until next time, have a good one.
Thanks, Jack.
Thank you.